look at dihybrid Punnett squares. It's super important that you understand monohybrid before moving on to dihybrid. So if you don't understand monohybrid, be sure to go back and watch that podcast. Dihybrid, just like you can guess from the names, is about looking at two traits. That di means two, and one cross. Okay, before we actually solve Punnett squares, we have to go over how to figure out the gametes that we would use to determine the possible offspring. So if we're looking at trolls again, remember trolls can be blue or green. This troll is heterozygous because blue is dominant, and this troll is homozygous recessive. The other thing is trolls can have long hair or be hairless, and having long hair is dominant and being hairless is recessive. All right, so now let's figure out the possible gametes the blue troll can make. Remember, because of meiosis, you're only going to have one allele for each gene in a gamete. In other words, you only have one B and one L in each gamete. So I'm going to start with my first big B, and I'm going to pair that with my first L. So I have big B, big L. I'm going to stay with my big B and move it to my second L. So I have big B, little l. I'm done with my big B, so now I'll go to my little b, take that to the first L. So I have little b, big L, and then go back to my little b, little l. Those are all of my possible gametes that the blue troll can make. Now the green troll is going to be a little bit easier. I only have little b's and little l's. So the only possible combination this troll can make is little b, little l. If you wanted to do it how we did with the big troll, you would just do the exact same thing and get 4 of the exact same. Little b's, little l's. Okay, you figure out the possible gametes for this blue, no-haired troll. It's heterozygous for blue, but because he has no hair, you know that's homozygous recessive. Pause the video and figure out the possible gametes. Okay, let's look at this together. So, take your big B, go to your first little L. Then you can take your big B and go to your second little L. That's actually the same, so we don't really need to show this second one. All right, start the little b, go to the first L, and then little b, second L. These two are the same as well, so you don't really have to show the second one. You can if you want to, it just makes extra work. Okay, now that you know how to figure out the gametes, let's go ahead and do a dihybrid. So you know that trolls can be blue or green, and they can be long-haired or short. So let's say we have 2 blue long-haired trolls. Okay, and they're both heterozygous for being blue and long. Okay, so the first thing I need to do is figure out their gametes. So I'm going to do this one first. So I take my first big B, go to my first L, and then take it to the second L, move to my lower B's, and I get these possible gametes. I'm going to go ahead and put these trolls' gametes up on top here. Okay, and as I'm sure you've already figured out, this guy, and I'm switching colors just so we can keep up with the difference between the gametes. His gametes are going to be pretty much the same. Big B, big L, big B, little B, big L, then little b, little l. And I'm going to put his down the side. Okay, I erased the gametes to give us some room. Now the next thing we have to do is figure out what possible phenotypes our offspring could be. So we know that they could be blue with long hair, or they could be blue with no hair. And if they're recessive, they could be green with long hair, or they could be green with no hair. All right. So these are our possible offspring. Let's go ahead and figure out our Punnett square. Okay, so I'm simply going to bring this blue down and then this green over. All right, so let's go ahead and do that now. Let's bring our blue down and our green over. All right, so keep your B's together and keep your L's together. That is your only rule. Keep your B's and your L's. We usually put our capitals in front and our lower cases behind, just so it's easier to figure out dominant and recessive. All right, I want you to pause the video at this time and I want you to fill out the remainder of this Punnett square. Okay, double check your answers with mine. Did you keep all of your B's together? Did you put your capital B in front of your lowercase b's and your capital L's with your lowercase L's? And did you keep all your L's together? Now what we have to do is figure out how many blue long-haired offspring we'll have. In order to be blue, you have to have at least one big B. So it could be big B, or big B, little b. And to be long-haired, you have to have at least one big L. So it could be LL or big L, little l. Okay? So we need like at least one big B and one big L. So let's take a look. I have a big B here and a big L here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 16 of my offspring have blue and long hair. I got the 16 because I have 16 total boxes. All right, now let's look for how many will have blue and no hair. So in order to be blue and no hair, I'd have to have one big B and two little L's. All right, so let's check it out. So I have 1, 2, 3. So 3 out of 16 would be blue and no hair. All right, now let's look for green and long hair. So to be green, I'd have to be little b, and then at least one big L. So 1, 2, 3. So 3 out of 16 would be green with long hair. All right, last but certainly not least is green and no hair. So this would be little b, little l. And as you can see, I have only one left of that. So 1 out of 16 would be green and no hair. Okay, so how do I tell if I'm right? Well, the first thing is add up your top numbers. So 9 plus 3 plus 3 plus 1, that equals 16, and it should equal 16. So I know that's right. The other thing you should know is whenever you have two parents that are heterozygous for both traits, so big B, big L, little l, and big B, and big L, little l. So they're heterozygous for both their B's and both their L's and both parents. It's important it's both parents. You're always going to have a 9, 3, 3, 1 ratio, with the 9 being the two dominant traits, the 3 being one dominant, one recessive, the other 3 being the other dominant and the other recessive, and the 1 being the two recessives. So you actually never have to do this Punnett square if you remember the 9, 3, 3, 1 ratio. Okay, let's try one more dihybrid. I'll set it up. I highly recommend once I give you your parents that you pause this and see if you can figure it out on your own and then double check with my answers. So you're going to have, in this case, a blue troll who has long hair, and this troll is going to be heterozygous for both traits, and it's going to be crossed with a green troll that has no hair. Okay, pause it now and see if you can figure this out on your own. All right, so you know green and no hair is recessive. Both of those traits are recessive. So this troll has to be little b, little b, little l, little l. All right, let's figure out the blue gametes first. Big B, big L, big B, little l, little b, big L, little b, little l. So I'm going to put that one on the top. And if you put them on the side, it doesn't matter. They can go on the top or the bottom. Okay, this troll can only make one type of gamete, little b, little l. Now, you can go ahead and fill out the whole Punnett square. What's beautiful about that is you'll get the exact same ratios. It's just more work. I am not going to fill out the whole Punnett square. I'm just going to fill out this one box, and I'm going to go ahead and ignore the rest of these boxes. All right. And again, if you filled them all out, that's absolutely fine. It's totally correct. It just is a little bit more work. Okay, so I'm going to bring my blue B's and L's down and my green B's and L's over. And hopefully I do this right. Remember, keep your B's together, keep your L's together, and make sure you put your capitals in front. It will really help you keep track of who's dominant and who's recessive. Okay, I'm going to clean this up a little bit over here just because I need some room. And we're going to, went a little too far there. And we're going to have to go ahead and figure out what our phenotypic possibilities of our offspring are. So you should have figured out that they could be blue with long hair, blue with no hair, green with long, and green with no hair. Okay, so in order to be blue with long hair, I need at least one big B and one big L. So do I have a big B and a big L? I do, right here. So that would be 1/4 of my offspring would be blue with long hair. I got the 4 because I have 4 total offspring boxes. Okay. To be blue with no hair, I need 1 big B and 2 little L's. So I have 1 big B and 2 little L's. So 1/4 of my offspring would be blue with no hair. All right, easy enough. Now I need to figure out how many would be green with long hair. So to be green, I would need to be little b, and at least 1 big L. Sure enough, little b, 1 big L. So that would be 1/4. And you can already guess how many will be green and no hair. So I need to be little b, little L, little L, little b, little L, little L. So 1/4. Okay, again, quick check, add up all my top numbers. Does it equal my bottom numbers? Yes, it does. 1 plus 1 plus 1 plus 1 is 4. So therefore, I've figured out the proper ratios. All right, guys, that's it for Dihybrids.